everyone, I wanted to make this quick video to talk about loops and how to create vectors in loops. So I'm going to create just a simple loop here. So for k equals 1 to 5, I'm going to say that vk, so the kth element of the vector v, is going to be 3 times k. Alright, let me briefly explain what's going on here. When this loop starts, k will take on the first value of this vector, 1 to 5. So this vector here is 1, 2, 3, 4, 5. And the first step of this loop, k will take on the value of 1. So when k is 1, we then run this line. So we get v, the first element of v is 3 times 1, because that's what k is in this case, equals 3. So the first element of our vector v will be 3. So I'm making this chart over here so that we can keep track. So when k is 1, v is a vector with a single element, and that element is 3. Okay. All right, then we update k. So in a for loop, the loop index gets updated automatically. So now k goes on to have the value of the next element in this vector, which is 2. So when k equals 2, this next line reads v parentheses 2, so the second element of v will be 3 times 2, which is 6. So now, in my chart here, k is 2, v is going, the 3 will still be there because that we set that to be the first element. All we did in this step was set the second element to 6. Okay, so you can see that v is getting longer as this loop goes on. When k equals 3, we're setting the third element. So now we're on this line with k equals 3 to be 3 times 3 equals 9. So here in my table I've got when k is 3, we still have 3 and 6, and the third element of v is 9. So I just want to point out that the only reason we're able to keep track of all the values that we've computed before is because we're using a vector here. We are indexing a vector with this variable k here. If I didn't have this parentheses k here and I just had v equals 3 times k, I would be overwriting the variable v at every step and not keeping track of all of the computations beforehand. I would only have access to the latest value of v, not all of the previous values. So that's why I'm using this index here, so that I can keep track of all of the values of v. All right, and then when k is 4, this line reads that the fourth element of v will be 3 times 4, which will be 12. So we still have the first element, second, third. The fourth element will be 12. And then finally, when k equals 5, the fifth element will be 3 times 5, which is 15. So when k equals 5, v now has a fifth element, so 3, 6, 9, 12, and that fifth element will be 15. And once k gets to the end of this vector, the loop ends. So we're done with the loop, and this is the final value of v. So just to illustrate, I'll run this section of code, and you can see that's exactly what happened. We started out with a single element 3, 3, 6, 3, 6, 9, 3, 6, 9, 12, 3, 6, 9, 12, 15, which is exactly how we kept track of it in our table. So how would we do this with a while loop? So let me go over here and write a while loop. So I'm still going to use the index k, but the thing to remember about a while loop is that the loop index is not automatically updated because a while loop checks a condition, not a loop index. So we have to manually create that loop index. I want my loop index to start at 1. I want to have the same starting value that I had in my for loop. So I'm just going to, outside my loop at the very top, I'm going to put k equals 1. That's my the first value I want in my loop index. And I want this loop index to go all the way to 5. So I'm going to say while k is less than or equal to 5, I'm going to do this computation. vk is 3 times k. And this is where a lot of people get stuck, is you have your loop index here, you're assigning values inside your loop, But you'll see that this isn't going to work. This is actually going to be an infinite loop. So if I run this section, you can see that, I don't know if you can tell that this is blinking down here, and my scroll bar is going a little nuts. So I need to hit Control-C, exit that loop, because I'm just getting three, hundreds or thousands of times here, and I'm not exiting my loop. So let me clear this. The reason that that's an infinite loop is that my condition I'm checking is if k is less than or equal to 5. I set k to be 1, and I never updated the value of k. So this is always true. It's always checking, is 1 less than or equal to 5, which is always true. So this loop will just run forever, setting v, the first element of v, to be 3. That's why we kept seeing that 3 over and over again. So what I need to do is make sure that k moves on and like steps up by 1, so that I'm actually at the next step of the loop, I want to access the second element of v, and then at the next step I'd like to access the third element of v. So I need k to go up. I need it to increase by 1 with every step of the loop. So what I'm going to do is put k equals k plus 1. Now this notation here, this is overriding the variable k with itself plus 1. So that's how you increase k by 1 at every step. You replace it by itself plus 1. And now this will cause us to exit the loop, because at some point k will no longer be less than or equal to 5. At some point k will be greater than 5, because I'm adding 1 at every step, and the loop will exit. So I'm going to scroll down and keep track of the values in this new table here. Just move some of these tables out of the way. So here's my new table that I'm going to keep track of. And I'm actually going to insert another column here, because I want to keep track of the loop iterations. And by iteration, I just mean how many times the loop has run. So outside the loop, so before the loop even starts, I have k equals 1. So outside the loop, k is 1. V doesn't exist outside the loop. Nothing says that v exists before the loop starts. So before the loop begins, v doesn't exist. When I go into my first iteration of this loop, so the first iteration, I check this condition. Is k less than or equal to 5? This is asking, is 1 less than or equal to 5? Yes, it is. So this line and then this line will run. So the first line that runs is that the first element of v is set equal to 3 times 1. That's going to give me a 3. So the first time this runs, v has 1 element, and it's 3. And then this line runs. This says that k is going to be equal to itself plus 1. And right now k equals 1, so 1 plus 1. This will overwrite k to now be the value of 2. So the first iteration of this loop, k becomes 2. Now we check this condition. Is k less than or equal to 5? 2 is less than or equal to 5, so now I will perform these lines again. And this will give me the second element of v will be 3 times k. At this point, k is still 2. We haven't changed it yet, but we will. So we get that in the second iteration, v is going to be 3 and then 6. At the very next step, we update k by itself plus 1. Well, itself at this point is 2, so 2 plus 1 is 3. And we keep going. At the third iteration of this loop, we ask, is 3 less than or equal to 5? It is. We set the third element of v to 3 times 3, which is going to give us the 3, 6, and 9. And then we update k again. K is itself plus 1. Well, itself is 3 at the moment, so 3 plus 1 is 4. K gets overwritten to be 4. And then at the fourth time this runs, we ask, is 4 less than or equal to 5? It is. We get that fourth element of v, and we put k is itself plus 1, which is 4 plus 1. We get 5 here. And it actually runs one more time because it asks, is k less than or equal to 5? Right now, k has a value of 5, so this is still true. We'll do a fifth iteration. V will now be updated to 3, 6, 9, 12, 15. K gets updated to 6. And now, when I ask, is k less than or equal to 5, it's false because k has a value of 6, so the loop ends. Okay, so end loop. I'm going to do a follow-up video because I'm probably running out of time on my screen recording right now. I'll do a follow-up video showing you how to do a computation and keep track of that computation in a separate vector. So it's going to be a slightly different video, but a similar idea. So I'll make that right now.